Hello, everybody. It is my pleasure to introduce the next session, Certificate Transparency, Detecting Malicious Certificates and Phishing Attacks, with speakers Bartos Nemixura and David Huang. Help me introduce them to the stage, or bring them to the stage.
Hi, thank you. My name is Bart. I work on product security as a software engineer.
Hi, my name is David Huang. I'm a security engineer on the product security team at Facebook.
So thank you for joining us this afternoon to listen about certificate transparency and the ways it can help us detect malicious certificates and phishing domains. So to start off, I want to share with you this little reflection that I had recently when we were preparing this talk, which was that we engineers and developers often think about technology and the ways it can look like in the future. But if you work in the security space, as we do, and you ask that question today, it would be almost impossible to predict what security threats, vulnerabilities, or attack scenarios we're going to see on the internet, for example, 5 or 10 years from now. So what we often do in security instead is we try to look back into the past and see what are the different trends, what are the patterns, and most importantly, are we going in the right direction to solve these potential threats that we might see in the future. So in order to cover this area a little bit, but also give you necessary historical context for the rest of this talk, I would like to invite you for a quick time travel. This is January 2008, and this is how Facebook's login page looks like at the time. So the design of this page, although slightly outdated and perhaps even familiar to some of you, is not the only thing that you should be paying attention to. The thing that should require way more attention is the address bar and the lack of just one small little letter, the letter S, because it indicates lack of HTTPS protocol and therefore lack of the encryption of the content in transit. In 2008, very few sites use HTTPS and majority of the internet uses HTTP. So let me explain why HTTP is so bad. See, in 2008, the fast internet connection is not really available everywhere you go, and certainly not in your pockets. So you might find yourself browsing the internet at your favorite local coffee shop or maybe an airport, connecting over an unencrypted Wi-Fi connection to a router at your location. Every single packet that you send would be routed over the internet to the final destination, to the service that you are using. But if you were using HTTP, all these packets would be sent in the plain text, which means that anyone in the line in that connection between the client and the server could see the content in transit. The attackers could not only see the content in transit, but also tamper it. The attacker could be a person sitting next to you, trying to spy on your messages. It could be a foreign agency trying to compromise your accounts, or an internet provider trying to inject JavaScript and cookies into your headers to track your advertisement sales, for example. So that's obviously terrible, but fortunately, we knew the solution to that. If the service enabled TLS, transport layer security, and was accessed over a secure protocol, such as HTTPS, those man-in-the-middle attacks would no longer be possible. So in 2008, we did roll out an encrypted version of our login page on Facebook. And immediately after doing this, we started seeing positive real-world implications in a drop of stolen accounts and compromised credentials. So that was a great positive impact. But since then, we've also seen an incredible push from the community towards adopting HTTPS. We've seen a rise of companies such as Let's Encrypt, which offer affordable ways of obtaining certificates. They now maintain over 90 million of active free certificates. The browser vendors have made it less desirable to use HTTP protocol by restricting certain APIs only to HTTPS websites. They also render special UI elements to indicate secure connections and distinguish them from those that are insecure. According to Mozilla, the web went from 46% up to 67% encrypted page loads in just about a year, which is amazing. And recent research on the HTTPS adoption on the internet tells us that over half of the major websites on the internet now use HTTPS. So the question is, have we as the industry made the progress in the overall improvements of the TLS ecosystem? I think the answer is clearly yes, but we still have a long way to go. However, assuming the perfect world, where everything is HTTPS, how do you know that the websites you're browsing to are finally the ones that you want to use? That no one is watching the traffic and no one is trying to trick you? Well, there are two different indicators that anyone can use just by looking at the address bar. The first one is the certificate, and the second one is the domain. Those two indicators effectively present two different kinds of attacks. For example, what if certificate authority misused a certificate, or the certificate itself is just malicious? Or, on the other hand, what if the domain that you're looking at is not really pointing to the service that you intended to use, but instead to a phishing website? We will cover both of these attacks in today's presentation, and to start, we will focus on certificates and an open framework, certificate transparency, which helps us detect these certificates. And David will talk more about it.
Thanks, Bart. So for those who haven't heard of certificate transparency, let me give you some background. When you visit a website over HTTPS, how do you know whether you're connecting to the legitimate server or a malicious one? In the TLS ecosystem, websites need to get a digital certificate from the certificate authority and present this certificate to the browsers. So browsers can reject the connection if the certificate is invalid. However, this system isn't always foolproof. For example, what if the certificate authority misissued a certificate for your website to someone else? Or what if the certificate authority got compromised by hackers? Such an attacker would be able to use fake certificates to impersonate your website and spy on users. And although this might sound unlikely, there are over dozens of certificate authorities trusted by browsers, so the attacker only needs to compromise the weakest link. In fact, several years ago, a prominent Dutch certificate authority called DigiNotar was compromised by hackers, and the attackers were able to obtain fake certificates for several popular domains, or several popular websites, including Gmail and Facebook. And they used the fake certificates to spy on users in Iran. So this was really bad. Fortunately, the industry has come up with a solution called certificate transparency. The basic idea of certificate transparency, originally proposed by Google, is to make all certificates publicly logged and auditable. The certificate authorities will submit all new certificates to the public log servers, and browsers will start rejecting certificates that are not publicly logged. In addition, the certificate transparency framework allows any interested party to monitor and audit these public logs, so they can also watch for any suspicious certificates or misbehaving certificate authorities or even malicious log servers. As an early adopter of certificate transparency, Facebook has been monitoring certificate transparency logs since 2015. And our monitor fetches certificates from over dozens of public log servers and alerts our developers whenever we detect any unexpected certificates for our domains. This monitoring service has detected multiple misissued certificates for domains that we've owned and prevented them from being used. So we found this monitoring service to be really useful, and we've decided to make it available to everyone. So you can also use our monitoring services easily without building it from scratch. Next, I'm going to walk through our monitoring tools to show you how you can use our tools to detect malicious certificates for your website. First, we provide a search tool in our developers site. This allows you to search for certificates for any domain. For example, you can type in a domain name such as facebook.com into the search box, and it'll return a list of certificates for facebook.com or its subdomains. You can click on Show Details to see more information for each certificate, as well as download the raw certificate file. We also provide a set of Graph API endpoints that allow you to search for certificates programmatically. I'm using the Graph API Explorer for demonstration, but you can do this in your systems. For example, you can use the certificates endpoint to query a domain name such as facebook.com, and select additional fields such as the domains and issuer name. And it'll return a list of certificates that match your search criteria. You can also search certificates directly by the ID, and then you could query additional fields on that certificate, such as the certificate hashes, using the same API. Now, in addition to providing search, which allows you to pull data from our servers, we also provide certificate subscriptions, which allows us to push certificate alerts to you whenever our monitor detects a new certificate for a domain you're subscribed to. So to add a subscription, simply type in the domain name that you want to subscribe to, such as facebook.com, and select the type of notifications that you would like to receive, and you can subscribe. After you're subscribed to a domain, whenever our monitor detects a new certificate issued for that domain, you can receive email notifications, mobile push notifications, as well as on-site notifications at Facebook. You can also integrate our monitoring tools into your own systems using our webhooks API. To set up webhooks, you'll need to go to your app dashboard and select the certificate transparency option. You'll need to provide your callback URL as well as the verification token that your callback endpoint needs to verify. And you can test your integrations using this tool by sending a test sample to your servers. And lastly, you'll need to click on subscribe here to activate that webhook. And after you've activated webhook, you can manage your webhooks using our Graphic API endpoints. We have endpoints that allow you to subscribe to a domain, unsubscribe to a domain, and list all existing subscriptions. If you found a misissued certificate, you can report it to the certificate authority that issued it, and you can ask them to revoke that certificate to prevent it from being used. Normally, this can be requested online through their websites. So I've talked about how you could use certificate transparency to detect malicious certificates for your websites. Next, I'm going to hand it over back to Bart, who will talk about detecting phishing domains.
Thank you, David. So the phishing domains was the second threat that we mentioned in the beginning of our presentation. A typical phishing attack that we see happening on Facebook is that the attackers would register a domain which would look confusingly similar to a facebook.com domain. This domain would later point to a deceptive website, which would be designed to trick users into revealing their credentials, personal information, or maybe credit card numbers. To make the domain look more credible, attackers would often register a TLS certificate for it, which they can clearly do as an owners of these domains, and the browsers would later display a green padlock or a secure word next to this domain in the address bar, which is actually really confusing to a lot of people because people often associate those indicators with the overall security or authenticity of the website, not really realizing that the only thing that these UI elements indicate is just the secure connection between the browser and the server of, unfortunately, a phishing website. So let's take a look at a few techniques that attackers are using to create those confusingly looking domains. We'll take a look at a few examples on a facebook.com domain. Sometimes it might be as easy as using the same character twice, such as $K in the first example. Sometimes attacker might change one character to another, such as using D instead of B. Those techniques are called typo squatting because they rely on a typo mistake or a misspelling that you might sometimes make when typing the domain name on a keyboard or your mobile phone. But there are also more sophisticated techniques. In the next example here, some people might think that this is a facebook.com domain, whereas in reality, Facebook is just a subdomain of another domain called com-evil.com. Those are called domain squatting or combo squatting. And these attacks rely on the combination of a keyword, brand name, or a legitimate domain name using as a subdomain of another domain. They are even harder to recognize on mobile phones, which have limited length of the address bar, because the full domain name is not often displayed to the user. And then finally, we have Unicode characters in international domain names. Those are characters that are confusingly similar to some of the ASCII Latin characters. In our example here, we changed letter E to another Unicode character that looks a lot like E, but it's not, and therefore it's a totally different domain. Some of the ASCII characters actually look identical to other Unicode characters, so this attack is very difficult to recognize. In fact, every single ASCII character has dozens of confusables. And if you try to use all of them to create many different attacks on a facebook.com domain, for example, you would be looking at over 87 trillion possibilities of distinct domains. So not only it's impossible to list these domains here on the slide, but it's also impractical to buy these domains to prevent these attacks from happening proactively. So what we try to do instead is to implement a defensive approach, ideally at many different layers and by many independent parties. We rely on domain registers to disallow Unicode characters in certain scenarios in international domain names. For the same reason, browser vendors would often change the rendering of the domain in the address bar to a punycode, another representation which makes it clear to the end user that the Unicode character was used. We also try to educate users about potential phishing attacks and trying to encourage them to increase their vigilance. But it's finally also on us, people who own the domains, people like you or me who maintain the services, to be aware of these attacks and respond to them as soon as we can. But how can you do that? How would you know that someone out there on the internet just registered a domain that looks confusingly similar to your domain? Today, we're excited to present a solution for this. We extended our certificate transparency monitoring tool to include another option called Phishing Alerts. You can now subscribe your domain in exactly the same way as David presented earlier, and now choose this new option, Phishing Alerts, to be alerted whenever Facebook detects a phishing attack on your domain. How does it work? Well, I mentioned earlier that attackers would often register a TLS certificate for their domains to make them look more credible. Whenever they do this, those certificates would be logged in public certificate transparency logs, the same that David just explained. Facebook will continue to look at these logs and look at every single certificate in there. We will then try to see what domains the certificate was issued for and try to see whether or not there was any phishing technique being used on some of the domains that we have in our subscription systems. If we detect that a potential attack is happening, we will notify the subscribers of the legitimate domains. You can choose many notification types, exactly the same as for certificate transparency notifications, such as email, mobile push, or notifications on Facebook. In addition to that, we also offer a webhook API, similar to our certificate transparency regular notifications, which you can control over another API endpoint. You can subscribe to many domains that you own. You can change these subscriptions over time and list off all of your active subscriptions. This is an example of a web request that would be sent to you if we detect a potential attack. We would include a certificate as well as the domains that we think are trying to impersonate your domains and the domain that you subscribed to. What could you do after receiving this notification? First of all, you can reach out to the browser vendors to ask them to display a warning for users not to proceed to these deceptive websites. You can reach out to third-party companies to help gather evidence against these phishing attacks. Having this evidence, you can then try to take down the domain, revoke the certificate, or take legal actions against the attacker, especially if you see this happening over time by the same actors. And finally, you can alert the users and ask them to increase their vigilance. So that covers the second threat that we wanted to discuss today, the phishing attacks. So in conclusion, we hope that the tools that we've presented today will help you detect those two different kinds of threats. We believe that TLS has greatly improved overall security on the internet, but there are still some important factors that might be exploited. And those are unfortunately rooted in trust. Trust in either certificate authorities or end users' vigilance. So whether that's a simple notification or more advanced integration with our monitoring system, we hope that these tools will help you detect suspicious activity early on, ideally before the attacks even happen. To learn more, visit our developers' websites at developers.facebook.com/tools/ct. Thank you very much.